Now I'd like to introduce Kiran Raza, who is a technical sales representative at ASACLEAN. She has an established background in the plastics industry. She holds a bachelor's degree in biomedical materials science and a master's degree in polymer science and engineering from the University of Manchester. Kiran?
Hi, thank you so much. And I would like to start off by just saying that I hope everybody's doing safe and well around the globe, wherever you are, and all your families at home as well. Right, so just a short introduction to myself. My name is Kiran. Today I'm going to be presenting 5 easy purging tips to minimize scrap and downtime in wire extrusion. Okay, so we'll start off with a quick introduction to the company. So we are ASACLEAN, part of Asahi Kasei. ASACLEAN is a worldwide leader in commercial purging compounds, part of Asahi Kasei, their parent organization. ASACLEAN was created in 1990. It's sold in more than 70 countries. Engineered for different resins and applications. Asahi Kasei is Japan's leading diversified chemical manufacturer, providing homes and construction materials, electronics, and also for the healthcare sectors. They do employ over 37,000 employees worldwide in more than 100 countries. So that's just a little bit of background on ASACLEAN and Asahi Kasei. Some people use an in-house purge compound. These are not always as effective as a commercial purging compound for several reasons. A couple of questions to ask yourself. Is your purge resistant to oxidation? Can you shut down and seal with your purge compound? So if you're leaving the purge in your machines overnight, when you go into startup, do you see scrap? Are you seeing degradation or black specks? And also, is your in-house purge easy to remove and displace with your next resin? Quite often you can experience a lot of waste products if you're not able to remove the previous resin quickly. So if you consider all of those questions, if your in-house purge compound is not able to tackle those issues, you probably do need to try a commercial purging compound. So why do we use purge compounds? To gain a competitive edge. Some of the benefits you will achieve: it will lower your production costs, increase your productivity. It's always important to consider your machine running costs when you're looking at using a purge compound. If without using a product you're experiencing hours of downtime or an increase in waste, that's usually going to be costing you more money. Investing in a purge compound, you can reduce your downtime, reduce your waste, and overall your savings will be a lot greater. So just a couple of things an overview of what I'll be going through in this presentation. I'll talk about grade selection, changeovers, that can be colors or resins, preventative purging, shutdown and sealing, screw pulls, and then a bonus tip will analyze the cost factors. So before selecting a purge compound, we will always go through a quick consultation with all of our customers. And some of the things that we're going to consider is the application. Is it injection molding? Is it extrusion? What's the problem? Are you looking for something to get through a color change, or are you seeing black specks or contamination? We'll also consider your processing temperatures and the resins that you're processing with. We have a very broad range of products, and we will recommend something that fits within your temperature range and to cover the range of resins that you're processing. So some of the variables that are involved, as I just discussed, the main thing we'll look at is what your process is. When it does come to your application, it's going to make a difference if it's multiple layers or lines in your extrusion, if you need to use a purge compound to pull your screw, if you need something to shut down and seal your machines, if you shut your machines overnight or over weekends, it's important to consider a purge compound to maintain your equipment. Also, as I mentioned, colour and material changes. For some people, it'll be colour if you're needing to get from black to white. That can be a difficult changeover. And for some people, it's certain resins that are more problematic than others. So when we're considering material changes, we will always look at the resin. In some instances, we'll make our purge selection based on compatibility of the base resin of the purge compound with your production resins. Another thing we look at is the type of purge. There's two types of purge predominantly that we offer: mechanical purge compounds and chemical. I'll talk about them in a little bit more detail. So first of all, if we consider grade specifically for wire extrusion. So one of the things that's very important in wire extrusion, or any extrusion in particular, is that of having clean extra day. If you see black specks, then you know that you have contamination in your machine. The issue with black specks is, say, if the screw and barrel is not cleaned adequately, you'll be likely to see them sporadically. There's no way of knowing when the black specks will appear. This is extremely disruptive. If you're in the middle of a production run and you begin to see black specks, it's not something that you want to come across. So one of the grades that we offer to tackle this is a glass-filled mechanical grade. This grade is called EX grade. It offers superior scrubbing compared to any of our other mechanical grades, and the glass-filled content allows it to remove really stubborn contamination. So if you have carbon buildup, or if you have a stubborn colour or resin that may be taking longer than usual to remove, a glass-filled grade can bring down that time from possibly hours down to minutes. In terms of resin waste, it can clean your machine in approximately 2 barrel capacities, which could be saving a lot of time and a lot of money in some instances. So now I'll discuss the product line that we offer. So as I mentioned, we offer mechanical purge compounds and chemical. So if we consider mechanical grades, the way these work, they are dependent upon pressure and agitation inside the barrel. So these grades, there's no soak time required. They are ideal if you're wanting to purge on the fly, so to speak. So if you're wanting to get in and out from one colour or one resin to the next quickly and effectively with minimal disruption to your process, by that I mean without having to change your temperatures, without having to stop the process, mechanical grades work extremely well. They usually can clean the machine, as I mentioned, in 2 to 3 barrel capacities. And effectively, they're letting the machine's power do the work. If we consider now chemical grade, these work very differently, and these will be recommended in instances of extrusion. Chemical grades can work very well in extrusion applications. They may be recommended if you have extreme contamination, and they're very, very beneficial for low flow areas. So sheet extrusion in particular is an example of somewhere where you would benefit from a chemical purge compound, as these grades are able to flow into the lower flow areas and offer a degree of cleaning in those areas that you would not get from a mechanical purge. So if we consider purging through the barrel, this diagram, as you can see, there's if you consider the thick black line being the outside of the barrel, you can see a green layer and a red layer. This is typically what you would see from a buildup of previous resin in the machine. So you may have extruded with a green colored resin. It's left a layer of residue on the barrel, you wouldn't see that coming out immediately in your extrusion process, but that layer is there. Over time, that layer is going to start to degrade. You'll then see the red layer. This you may have then followed with a red color, and this layer has then built up on top of the previous layer. So this is very typical behavior if you're not purging the machine with a commercial purge compound. There will be a layer of residue that builds up. If that layer of residue is left in there for a long period of time, it will start to degrade, and that's when you start to experience black specks. If we now consider the resin flowing out to the die, as you can see in this diagram, the edges of the die and those blue arrows kind of coming outwards represents the low flow areas in your extruder. So as I mentioned, these are the areas where, again, you're going to have a buildup of residue at the edges. You would need to determine a purge compound if you're looking to clean the buildup at the edges. You're going to need something that can reach into those low flow areas and remove the residue from the edges of the machine. If we now look at the screw, and again we can see in this diagram other areas where the residue buildup is quite prominent. So there will be buildup at the flights of the screw. We've already looked at the buildup at the barrel wall. The checkering and the nozzle are the sections of the screw where you will tend to see a fair buildup of residue from your previous resin. So this is a case study. Before I talk about the case study, this was performed with a wire extruder. The residue that we just saw building up in all the sections, the screw, the barrel, the nozzle also. As discussed, if not cleaned with using a commercial purging compound, that residue will begin to degrade, and it does take longer to clean and remove. So this case study was performed with a wire extruder. I think it was for a changeover for a particular resin. Now, without using a purge compound, the changeover was taking them 4 hours. Now, if we look at machine running costs for this particular company, it was $150 per hour, and the resin waste that they were accumulating was approximately 200 pounds. So one of the things we look at when we're using a purge compound, and the reason we use a cost-saving analysis like this, is we like to see what the ultimate cost savings are, not just the cost of the purge compound. So as you can see, when they performed the changeover using the AciClean purge, they were able to reduce the changeover time to 1.5 hours. So $150 per hour, that's more than half that they've reduced the downtime. Now looking at the purge compound, the amount of purge that was used is approximately 1/3 compared to resin waste. So even if, and the price of material, these are just examples, even if the price of the material is more than 2 times that of the resin, the cost saving achieved here is still almost 50%. So in this particular example, and this is a real life example, the annual changeover savings were $102,000 or 43%. So now I'll talk a little bit about preventative purging. So we will always try and incorporate a purge program with any of our customers to reduce the number of times that they would have to pull the screw or deal with contamination. Because if you leave residue in the machine for long periods of time and it does degrade and you do start to get black specks, that's when purging becomes more timely and more costly. Effectively, if you're being reactive with your purging, it's going to take longer and be more difficult to clean. If you're preventative purging and you stay on top of it, you prevent those issues from happening in the first place, it's going to take you a lot less time and cost you less money. So in this particular, these pictures that you can see on the screen, you can see the residue that's kind of built up on the screw. After using the AciClean, your screw looks very clean, and it's also important to remember this is going to maintain the lifetime of your screw as well. So I've talked about how the residue in the machine will start to degrade over time. Here's an example of how that happens. So if you consider the resin inside your machine, and here we've taken natural ABS, and we've done a study where the ABS is left at 460 Fahrenheit in the atmosphere, and then also when it's left in a vacuum. So if the resin is left in the machine and your machine is left empty, there's going to be oxygen in the barrel. So that represents what we're seeing in the first 4 pictures of the natural ABS left at 460. Now, after 15 minutes, you can see how the colour has started to darken. Over 30 minutes and then on to 60 minutes, the ABS has pretty much degraded. Once it's degraded to that extent, that's when it becomes, you start experiencing the black specks, and that's when it becomes difficult to remove. Now, when the ABS is left inside the vacuum, so here we've taken out the presence of oxygen. Oxygen is what's causing the oxidation and the degradation to occur. So if you go from the vacuum product after 60 minutes, you can see there's not much change to the colour. So you've prevented degradation of that residue from happening. And this is one of the things that we're able to do by shutdown and sealing. Sealing your machine with a purge compound is highly recommended. So this shows a live example. So previously we looked at the study of the ABS being left in oxygen and then also without oxygen. Now, if we take a look at these screws, on the left-hand side, we can see after running ABS at 460, even when the heaters are shut off, there's still heat inside the machine. So you can see from 1 hour to 5 hours, you can see the change in colour. So what we recommend is at the end of a production run, if you're going to be turning your machines off overnight or over the weekend, once you purge with the AciClean, leave the purge inside the barrel. So it's completely safe to leave the purge compound in, turn your heats off. As you can see, from the 1 hour to the 5 hours, leaving the AciClean inside the barrel, there's no change in colour. There's been no degradation. When you then go into startup and begin extruding with your next resin, if you take a look at the bottom 2 pictures, you can see the difference of the clarity on the screw. And that's simply by leaving the purge inside the barrel, prevents oxygen from coming inside the barrel. In turn, you've prevented degradation from occurring. Okay, now that we've talked about sealing the machines, which is the preventative action, which is always recommended as being the most cost effective, I'll now talk about screw pulls, because sometimes you do get to the point where you do have contamination. If you have severe contamination, the only way to tackle that is by removing the screw. Anybody who's had to perform a screw pull before will know the amount of time and effort that's associated with this. So again, the screw pull is the only effective option if you have a very difficult changeover, if you're very heavily contaminated. Using a purge compound to assist with your screw pull is going to help you in a few ways. One, it's going to reduce the amount of force that's required to pull the screw, reduces the time and effort, and also minimizes the manual cleaning. So quite often with a screw pull, you may be having to scrub at it with a wire brush, or leaving it in the oven to burn off any residue. But with the EX grade purge compound, you're able to eliminate those. And I'm going to show you a short video clip of the EX grade being used for a screw pull. If we now take a look at an example of a case study that was done with an injection molder who used the Acetylene EX grade to assist with one of their screw pulls, the cost-saving analysis here showed a very large saving. So normally the screw pull was taking them 12 hours. At $85 an hour machine running cost, that was over $1,000 in machine downtime. A screw pull can take 12 hours, in some instances 24 hours. If you're having to manually clean the screw, this type of downtime is quite common. So with the Acetylene EX grade, as you can see, they were able to bring that down to just 15 minutes. So just in the machine downtime alone, the cost savings there were very large. Amount of purge material used, obviously, without using any purge, there's no cost there. In this case, it was only 3 pounds of product was required to fill the barrel with the acetylene and then pull the screw. So the cost of the purge was extremely minimal. And in this particular case, we can see the annual screw pull savings, 350,000 or 96%. So this customer was obviously extremely happy. So after what I've discussed, if we consider this, quote by Peter Drucker, you can't imagine what you don't measure. This is one of the reasons why we complete a cost-saving analysis with all of our customers. If you don't measure the amount of downtime that you're experiencing and the amount of resin waste that you're getting, there's no way of knowing what the true cost is of your changeovers. So we look at, if we analyze the cost factors, we look at the cost per purge versus the cost per pound. So when we complete a cost-saving analysis with any of our customers, we consider the changeover time, the scrap rate, the production reject rate, and the lost production due to downtime. Only when you look at all of those factors as a whole are you able to get a true cost saving. Also important to discuss following direction to maximize efficiency. So as discussed, we offer a very broad range of compounds, mechanical grades and chemical grades, and even within those two areas, there's an extremely broad compound. Will be specific to whatever the needs are. Each compound will have instructions on how to perform the purge, and following those instructions is extremely important. So in the case of mechanical purge compounds, you'll be given recommendations to try and increase pressure inside your barrel. This improves performance and cleaning ability. In the case of a chemical purge compound, instructions may be to increase heat and allow a soak time to allow those chemical agents to clean effectively. So always important to follow directions. If in doubt, we have technical sales representatives always at hand to answer any questions.
Karen, I want to thank you very much for an informative session. Can a screw ever be damaged by cleaning compounds?
No, we do, by cleaning with the purge compounds. No, the purge compounds are they're designed to have a very low affinity to metal, a high affinity to the resin. So by nature, they're very effective at removing the resin, but not causing any damage to the screw.
Okay. We want to thank you again for a very educational presentation.
Thank you so much for having me.
Our pleasure.